everyone. Welcome to Subnetting a Little Bit. In today's video, we present an example of traditional subnetting based on the number of hosts. First, let's go over the 7 baby steps of subnetting. Step 1. Understand the requirements. This is probably the most important step. Step 2. Identify the relevant formula and solve it. Step 3. Use the solution to determine the subnet address map. Step 4. Use the address map to obtain the interval, transition octet, prefix length, subnet mask, and wildcard mask. For a refresher on steps 3 and 4, refer to the subnet address map videos in the series. Step 5. Identify all network addresses. Step 6. Determine all broadcast addresses. Step 7. Find the first and last usable host address in each subnet. We repeat, the most important step is understanding the requirements. Are we being asked to use traditional subnetting or VLSM? That is, variable length subnet mask, which is always based on the number of hosts. If the requirements say traditional subnetting, is it based on the number of hosts? Or is it based on the number of subnets? With traditional subnetting, every subnet will have the same number of hosts, and as a consequence, the same subnet address map, which in turn leads to every subnet having the same subnet mask, wildcard mask, interval, and transition octet. Let's say you are given this topology and asked to use VLSM. You would use the total usable addresses formula, or a power of 2 table, to determine the subnet address map for each subnet. If a topology is not provided, the size of each subnet would be explicitly specified in the requirements. If the requirements say to use traditional subnetting based on the number of hosts per subnet, and a topology is provided, use the number of hosts shown in the largest network. In this topology, you would use 900 hosts per subnet. Then use the total usable addresses formula to determine the subnet address map. If a topology is not provided, the number of hosts per subnet would be specified in the requirements. If the requirements say to use traditional subnetting based on the number of subnets, and a topology is provided, count the number of subnets in the topology. With this topology, depending on the requirements, it could be 4 or 5 subnets. Then use the total subnets formula to determine the subnet address map. If a topology is not provided, the number of subnets would be specified in the requirements. Let's look at a traditional subnetting example based on the number of hosts. Use traditional subnetting to subnet the address 192.168.1.0/24 based on the number of hosts per subnet. Each subnet should have 25 hosts. Determine the first 4 subnets. Step 1 is to understand the requirements. Focus on the type of subnetting, traditional, and based on the number of hosts per subnet, 25. Step 2 is to identify and solve the relevant subnetting formula. We use the total subnets formula, 2 to the s, when subnetting based on the number of subnets, and solve for s, where s is the number of subnet bits needed in the address map. We use the total usable host addresses formula, 2 to the h minus 2, when subnetting based on the number of hosts, and solve for h. In this case, h is the number of host bits needed in the address map. We subtract 2 because, as we know, the network and the broadcast addresses cannot be assigned to a device. In this example, the requirements say 25 hosts per subnets. So we are subnetting based on the number of hosts. This means we will use the total usable addresses formula. We set the total usable addresses formula to be greater than, or equal, to the number of hosts per subnet specified in the requirements. We need to identify the smallest value of h that satisfies the equation. 2 to the h minus 2 greater than or equal to 25. A value of 5 for h satisfies the equation. This will give us 30 usable addresses per subnet. This means we need 5 host bits in the address map. Alternatively, we could find the number of host bits required by using a power of 2 table. Look at the column showing the total number of usable addresses. Identify the smallest value meeting the requirement. 30 usable addresses in this case. Then look at the host bits column and note the value of h, which equals 5. This confirms we need 5 host bits in the address map. Step 3 is to determine the subnet address map. Since the native class of the given address is of the class C variety, we will need 3 uppercase N's in the address map, as noted in the native address map of a class C address. Let's start with the 3 uppercase N's. We determined h was 5 in the previous step. So we add 5 host bits. And then add enough subnet bits to account for 32 bits. So add 3 subnet bits. This is the subnet address map. Here's a bonus tip. Since there are 3 S bits in the address map, when we apply the total subnets formula, we see there are a total of 8 subnets possible with this subnetting scheme. Applying the total addresses formula using the 5 host bits, we see there are a total of 32 addresses per subnet, of which 30 are usable. However, we already knew that, so this just confirms it. In step 4, we use the subnet address map to determine the transition octet, interval, prefix length, subnet mask, and the wildcard mask. The transition octet is the octet where the rightmost subnet bit resides. Notice it is in octet 4. Therefore, octet 4 is the transition octet. The interval is the value of the rightmost subnet bit in the transition octet. By placing the transition octet in a bit table, we can see the value of the rightmost subnet bit is 32. This is the interval, 32. The prefix length is represented by the total number of network bits. The address map shows 24 bits in the first 3 octets and 3 subnet bits in octet 4. This gives us a total of 27 network bits, so the prefix length is /27. The subnet mask helps us determine the network and host portions. For the subnet mask, set the network bits to 1 and set the host bits to 0. This gives a subnet mask of 255.255.255.224. The wildcard mask is the inverse of the subnet mask. Set the network bits to 0 and set the host bits to 1. This gives a wildcard mask of 0.0.0.31. In step 5, we determine the network addresses for the first 4 subnets as noted in the requirements. We will use this table to facilitate the process. Let's populate the table with the classful octets as they will not change. For the first network address, use the original address provided in the requirements. and then apply the prefix length determined in the previous step. This gives 192.168.1.0/27. To get subsequent subnet addresses, add the interval to the transition octet. If there are any remaining octets, set them to 0. But in this case, the transition octet is the 4th octet, so there will be no remaining octets. Now that we have the first subnet, add the interval of 32 to the transition octet. This gives 32 in the 4th octet of subnet 2. Then apply the prefix of /27. Once again, add the interval 32 to the transition octet. This gives 64 in the 4th octet of subnet 3. Then apply the prefix of /27. Repeat the process. Add the interval 32 to the transition octet. This gives 96 in the 4th octet of subnet 4. Then apply the prefix of /27. Here we see all the network addresses. In step 6, we determine the broadcast addresses. A few options are available. Some of them are listed here. Feel free to pause the video to review these. To get the broadcast for subnet 1, subtract 1 from the transition octet of subnet 2. This gives 31 in the transition octet. To get the broadcast for subnet 2, subtract 1 from the transition octet of subnet 3. This gives 63 in the transition octet. To get the broadcast for subnet 3, subtract 1 from the transition octet of subnet 4. This gives 95 in the transition octet. Another method of determining the broadcast address is by adding the wildcard mask to the network address. We will use this method for the 4th broadcast address. Add the wildcard mask of 0.0.0.31 to the network address of 192.168.1.96. This gives .127 in the transition octet of the broadcast address. These are the broadcast addresses. In step 7, we determine the first and last usable host address of every subnet. To determine the first usable, simply add 1 to the 4th octet of the network address. For subnet 1, adding 1 to 0 gives .1 in octet 4. For subnet 2, add 1 to 32 to get .33 in the 4th octet. For subnet 3, add 1 to 64 to get .65 in the last octet. And finally, for subnet 4, adding 1 to 96 gives .97 in octet 4. The highlighted addresses represent the first assignable address of each subnet. For the last usable host address, subtract 1 from the 4th octet of the broadcast address. For subnet 1, 31 minus 1 gives .30. For subnet 2, 63 minus 1 gives .62. For subnet 3, 95 minus 1 gives .94. And finally, for subnet 4, 127 minus 1 gives .126. The highlighted addresses represent the last usable address of each subnet. We are all done. These are the first 4 subnets. Notice how all the addresses run sequentially in increasing order. This table summarizes the process of obtaining the noted parameters. That's it for now. Thanks for watching. And remember, nothing worthwhile comes easy. So go forth and subnet a little bit.